we use a key string generator to generate a secret key of 64 bits. If one bit is exchanged, the entire block, depending on this block or this bit, will be corrupted. Finally, the key generator is going to take back the key and get only the plain text. It feels to the attacker or adversary that it is randomly selected or randomly generated key. Hello students, welcome to the next session of Network Security. I am Dr. Soumyashri from Department of Computer Science, Vidhyaashram, first grade college. Welcome to the session. This session is all about knowing the use of stream ciphers. How do we use, or what are the methods of using stream ciphers, and the remaining modes of enciphering and deciphering in the block cipher methods. Okay, let's start this session. The first thing is to know the next mode of operation or next mode of encryption and decryption in the block ciphers. Okay, the thing is, the name it has given is the output feedback mode. Okay, in output feedback mode, each bit in the cipher text, you know about the last type of mode, isn't it? CFB mode, where the shift registers were used. In this, each bit in the cipher text is independent of the previous bit. What was the disadvantage of CFB was the blocks depend on the previous block, they are not independent. So if one bit is erroneous, if one bit is exchanged, the entire block depending on this block or this bit will be corrupted when the CFB mode. To avoid that, in the OFB mode, output feedback mode, one bit is made independent so that the error will be avoided for the following bits. Okay, independent of the previous bit or bits, maybe one bit or more than the bits. One bit will be independent of the previous bits so that the error propagation will be avoided in this mode of operation. Okay, this is the encryption process in the OFB mode. Here we have the shift register. The n bits of normal text or the plain text will be given to the shift register. There, encryption algorithm is executed. Then a temporary register is given where the temporary cipher text is obtained. This temporary cipher text of R bits or R bits of the temporary register were taken and are XORed with the R bits from the plain text. Then you get a new set of R bits, which is a cipher text 1. This will be taken to the second round. In second round, the same procedure is repeated. In this, one bit will be changed or one bit will be independent of the previous bits, so that if there is any error in the previous bits, it will be avoided at that particular position and the remaining following bits will normally propagate or get to the ciphertext procedure. Okay, here we have the diagrammatic representation. This is the diagrammatic representation of the OFB mode. Only one bit is going to be changed from that of the CFB mode. If you take the OFB mode, consider the OFB mode as a stream cipher. We follow the same thing. Only one bit will be independent, but other will be same as it is. So it will depend on the previous blocks. Blocks propagate or communicate in series. So it is called as CFB mode as a stream cipher. It is going to encrypt that in the block method. But since The current block or ciphertext generation depends on the previous block. You can consider it as a stream, isn't it? It depends on what is the characteristic of stream cipher is one set of bit depends on the previous bits, isn't it? Same thing is happening in the OFB mode as well as the CFB mode. So that is why you can discuss in the form of a stream cipher, how it works if you consider it as a stream kind of cipher. Here we have the key generator with n bits in the shift register. Encryption algorithm is applied. The temporary register stores the n bits of the intermediate ciphertext. So R bits are taken as the key for the ith step, combined with R bits from the plain text. Then encryption is done here with R bits at the CI stage. Then we go to the next step, isn't it? It will be moved through the insecure channel with a less kind of security. Then you'll get R bits with XORed with R bits of plain text to get the set of R bits with key I, which is stored in the temporary register I, and it gets stored in the n bits as n bits in the shift register. Finally, the key generator is going to take back the key and get only the plain text. Okay, this is how we can consider it in a stream cipher. When you look at the security issues in the OFB, again in this, the patterns are not preserved. They are going to be generated with different key sets. When you look at the error propagation, it is advantageous over the CFB mode because a single bit error in the ciphertext affects only the corresponding bits, only the neighboring bits, not the subsequent bits, because in that one bit will be independent in each block, which avoids the propagation of the error to the subsequent bits. So error generation will be avoided or error propagation will be successfully handled in the OFB mode. The next kind of mode we can discuss is the counter mode. The last category is the counter mode, or the CTR mode is called. In the counter mode or CTR mode, there is no feedback. They are independent. Encryption and decryption are independent. The pseudo-randomness, it is not actual, but random. It is felt that the randomness or keys are generated randomly, but it is sequentially generated, but it feels to the attacker or adversary that it is randomly selected or randomly generated key. So it is called as the pseudo-randomness. In the key stream is achieved using a counter. We are using a counter to avoid or to make a perception of pseudo-randomness for the key generation. Even though it is sequential, a randomness is provided, or randomness picturization has been given for the adversary using the counter. That is why it's called as the counter mode. In the previous modes, we used registers. In this mode, it is all about the counter. The encryption is happening in, how it is happening in counter mode is, we have the counter here, counter, how many bits it can store. So now we have the initialization vector getting the n number of bits. It is applied with an encryption algorithm, n bits stored in the register, random n bits. So it will have random n bits for which the algorithm is applied, and you get n number of bits along with the key set K1 combined with the n bits of the plain text, XOR both, and you will get n bits of the ciphertext 1, block of 1. But this is propagated over the channel as a stream cipher. Okay, it is not going with the second step of encryption. Second block. So second block is independent of the first block. Each block is independent. It is not going to take any feedback from the previous encryption. Okay. Each bit or each set of encryption is independent and it gets the ciphertext using the counter value. Okay. N number of bits from counter will be XORed with n number of bits from the plain text to generate n encrypted bits. Okay, so this encrypted bit is propagated over the channels until the nth step or n minus 1 step. Each time the next encryption is done, counter is incremented. Okay, counter may be incremented based on the number of bits, which counter is fixed. If it is 8 bits, 1 byte increment will be done. If it is 16 bits, 2 byte of increment will be done. So counter value is incremented based on the number of bits in the counter, and for each block the counter is going to be incremented. Okay, this is how you can use the counter mode or the CTR mode to encrypt the blocks. Okay, how do you pass this to the receiver is as a stream cipher, R number of bits. So it is not going to the next step. Independently, it is channeled over an insecure network path and it is going to be received by the receiver like we do in the YouTube or any videos. Videos if you take, sometimes videos take the feedback from the previous because there may be loss of link between the two blocks. So sometimes they use OFB or CFB mode to send the block of packets or set of packets over the network path. There may be some sequences which doesn't depend on the previous one and is independently sent to the receiver. The counter is that type of encipherment where each block is independent of each other and it doesn't depend on the feedback from the previous step of encryption. All right. Now we have the comparison between the different modes in the block cipher. Here we have the ECB, the CBC, CFB, OFB and CTR modes. The CFB, that is the ECB and CBC modes, are block ciphers. They are encrypted as blocks only and are sent as a block. But the CFB, OFB as well as CTR are stream ciphers. They'll go in a series of manner. Here both are maybe shuffled blocks which reaches the receiver. Receiver has to rearrange the blocks using the key set. Okay, key will be there with the each block ID. So using the ID, they have to rearrange the blocks. All right. So data unit size you can use is n number of bits you can use. Here also n number of bits. Here it is R number of bits. R number of bits that will be sent for each block will be less than or equal to n. Same with this. Here again, n number of bits will be sent. Since they uses feedback and less number of bits, for more number of bits, we can use these three modes, that is the ECB, CBC and CFB, whereas for chunks of blocks, bits are less for propagation. In such a case, you can use the CFB and the OFB modes. Okay. So ECB description is each n-bit block is encrypted independently with the same cipher key. What about the CBC is each block is first exclusively ORed. This doesn't follow that. The difference is exclusively ORed with the previous ciphertext. About the CFB, each R bit block is exclusively ORed with the R bit key which is the part of the previous text and it is stored in the register, shift register. Okay. OFB is same as SFB, but shift register is updated by the previous R bit key. Okay, one bit will be independent. CTR is same as OFB, but a counter is used instead of the shift register. Alright, so these are the various modes of encryption and decryption in the block ciphers. Now let's move on to the next thing, that is the use of the stream ciphers. How do we use the stream ciphers for encryption as well as decryption? Let's start the concept of use of stream ciphers. Where do we use the stream ciphers? Okay, the use of stream ciphers is needed when you have the need of transmission of small set of characters or bits. So there are 5 modes of operation in the block type of mode, isn't it? So block ciphers for encipherment can be done for messages or files which are in larger units, paragraph wise, page wise text has to be sent, longer videos and audios has to be sent, images with higher resolution has to be sent. In that large and varying size of packets are there, or varying type of data are there, size of data, then you can make use of the block ciphers. Then there will be some situations where it needs the stream ciphers for enciphering, which are small units like set of characters or set of bits. In such a case, you can make use of the stream ciphers. In this, we have set of stream ciphers, but we are going to study only 2 types of stream ciphers. The first one is the RC4. Okay, so RC4 was a type of cipher method, stream cipher method, which was developed by the RSA labs, which gave the name RS4 for the stream cipher method. RS4 is a symmetric byte-oriented stream cipher. It depends on the byte, okay, 8 bits or a byte with a variable length key size. Key size will not be fixed. Key size will be varying, in which a byte or 8 bits of a plain text is exclusively ORed. We use 1 byte of data from the plain text, which is exclusively ORed with a byte of key. Byte of plain text exclusively or XORed with byte of key. Okay, to produce the byte of cipher text. Example, so the RC4 has 2 parts. One is the key scheduling algorithm. It is called as the KSA, and pseudo-random generation algorithm to feel the adversary or the attacker that the key is randomly generated. Okay, so we have 2 sets of algorithm. One is key scheduling algorithm, that is how much, what kind of key or what set of key is used for ciphering, and pseudo-random generation algorithm. Okay, along with this, we use a state. Okay, so RS4 uses the concept of state. You know about the matrix representation of the state, isn't it? So the set of keys can be 0 to 255, or you can have total 256 bits of key. Okay, in the RC4. So it contains 1 to 256 bits of keys. From this, each byte will take only 8 bits of or 1 byte of key from the key set of 256 bits. Okay, we are using it as a matrix. As we know about the state, it is represented as a matrix. If you take S0 as the first column or first key set in the set of keys, you get yes 256 bytes of, you can use 1 to 256 bytes of key sets. Okay, for each byte of plain text, you can use any of the S0 to S255 set of bytes. You can randomly select the bytes. Here we have a diagrammatic representation of the stream cipher using the two algorithms. Okay, here we have state and key initialization. The first algorithm is key scheduling algorithm. Then we have the pseudo-random generation algorithm. Now we have the first step with the KSA, key set generation. Key initialization is done only once in the ciphering method. So we generate the set of keys for, if you consider maximum of cipher text or state with 255 bytes, we have key with 255 bytes, maximum of 256 bytes. Okay, initial state permutation. Once key is initialized, you are going to permutate the key sets, okay, key bytes, mix with key bytes and permute. So you are going to permute the state values. Okay, we use S0 to S255 and key sets K0 to K of 255. We are going to initialize the state and the key generation, key initialization in the first step. Second step is combining these two, S and key. Okay, text and the key. Both will be mixed and key bytes are permuted. Okay, so that there will be shuffling of the bytes in the packet. Okay, next followed by the state permutation for key stream generation, the first step. Then again for the second set of byte, first byte, second byte up to n number of bytes based on how many bits of data are there in the plain text. Okay, we have the permuted state values with the first set of 8 bits, that is K0. 8 bits of plain text is XORed with 8 bits of the key to get 8 bits of cipher text. This is the first byte, second byte and the last byte. So it is continued in the same way. This is done first time. Then every step for the plain text is taken with only 8 bits. 8 bits is encrypted at a time and the last byte will take the permutation and mixing and gets the XOR operation done with the 8 bits of the plain text combined with the 8 bits of key to generate 8 bits of cipher text. Okay, so this is how the RC4 is going to use the stream cipher method. Okay, the RC4 key scheduling algorithm will be like this. Starts with an array of S. So array of S will be taken from 0 to 255. Then use key to shuffle the S. So S set of text or set of bits will be shuffled in the next step. The S forms internal state of the cipher. How does the ciphering is done will be based on the permutation of the S set. Okay, given a key K of length L bytes, we are going to permutate the S, that is the state bits. Now we have the scrambling pseudocode for this. We use from 0 to 255 having the first bit, then the first initialization, the first step of encryption. For we take the key from 0 to 255. Now what we take is J equals J plus S of I, that is S of 0 plus K of I, first key, by modulus of 256. Then swap the things, that is the first two steps using in the KSA scheduling algorithm. Then it will be going to permutate the KSA algorithm. So this is the KSA algorithm in first two steps. So this uses the KSA algorithm, and this uses the PRGA algorithm, okay, to permutate and get the cipher text in the RS4 ciphering, right? Now, let's move on to the next kind of ciphering, that is the A5 bar 1. So, what does this will do? This is another type of stream ciphering. A5 bar 1, 5/1 is a member of the A5 family of ciphers. So, A5 is a set of ciphering method where 5/1 is one of the type of the ciphering method used in the A5. Okay, it is used in the GSM mobiles. So we know about the GSM mobiles, isn't it? They used to encrypt the data in the GSM mobiles using the A5 method. The Global System for Mobile Communication, GSM, a network for mobile telephone communication which was used earlier. In that case, in that mobile network, they used this A5 bar 1 stream ciphering method to encrypt the data which is transferred between two GSM mobiles. Okay, we have the general outline for A5/1. We use a key stream generator to generate a secret key of 64 bits. We use a secret key of 64 bits. From that secret key of 64 bit, one bit is taken at a time for and is provided to the key stream buffer of capacity 228 bits. Now we have the A5 bar 1 where the general outline is like this. So secret key of 64 bits will be in the key stream generator which generates 64-bit secret key. From this, one bit is added with the 228 bits in the key stream buffer. Because why do you need 228 bits is in the GSM communication or GSM network, each plain text frame will be of size 228 bits. To XOR them with the key, we use 228 bits of frame, key frame in the key stream buffer combined with the secret key of 1 bit. Okay, the XOR operation of this generates a cipher text with the 1 bit of secret key that is used from the 64 bits. Okay, so that means you will get cipher text frame of 228 bits. Okay, this is the A5 bar 1. How do you generate the key is uses 3 LFSRs. LFSR stands for the linear feedback shift register. Linear feedback shift register means it is a sequential shift register which takes the input from the previous one. Okay, shift register is shifting the bits to the right. So it will shift the register bits to either right or left. We will have right shift register and left shift register. Both will be there. So you can use any of the shift register with a feedback in a linear manner, which is called as the linear feedback shift register. So the A5 bar 1 ciphering method uses 3 LFSRs with 19, 22 and 23 bits. Okay. Now we use the 3 red boxes with 19 bits with correlational algebraic sequence are used in the most of the functions. They use the XORing of the operation with each of the register. So it generates 228 bits of frame with the cipher text and is carried out along with the 19 bits, 22 bits or 23 bits of LFSR. So they use these 3 boxes or 3 LFSRs to perform the ciphering method in the stream cipher. So this is about the stream ciphers, that is RC4 and A5 bar 1. Okay. Let's look at the other issues. The encipherment using the symmetric key block or stream cipher requires discussion of the other issues. What are those other issues is how to manage the key. How do you manage the key in this? Okay, when you have the receiver and the sender need to share a secret key between each other to securely communicate using a symmetric key cipher. How they are going to do that is, if there are n entities in the community, if there are n paths, they use n into n minus 1 by 2 keys are needed to make it stronger, and cryptanalysis will be difficult for the set of keys. How many set of keys we need is, if you have n number of entities, then you need n into n minus 1 bar 2 sets of keys are needed. Along with that, different key symmetric ciphers need keys of different sizes. If we use different type of ciphers in the symmetric key, we need different sizes of key, isn't it? So capacity or the key need of each of the ciphering method is different from one another. So you need keys of different sizes. The selection of the key must be based on the systematic approach to avoid a security leak. So you have to use minimum number of keys, maximum number of keys. All must be with a systematic approach. The keys need to be chosen randomly. The main requirement of any cipher method is the key must be randomly generated. It is not the sequential one. It must not be sequential one. It must be random to avoid the attackers from getting the cipher text and the key. This implies that there is a need for random or pseudo-random number generator. We use the number generators to randomly generate the key. Okay, so this is about the use of the stream and the block ciphers in either DES or AES. Next session will be all about the issues in the modern symmetric key ciphers. Okay, thank you.